9 is this long thing about person B is 2 times older than person A, and so on and so forth. One thing that's often helpful, and I know I find it helpful, I'm kind of a visual person anyway, but like, a diagram, some sort of a diagram to kind of lay things out. I mean, we have 4 people, A, B, C, and D, kind of progressively getting older and older. So, 4 people, A, B, C, and D. So here's our 4 people. Another thing you notice here is that we don't know anybody's actual age. All we have is comparisons. B is twice as old as A, and C is twice as old as B, and D is 5 times older than C, and so on. We have these comparisons, but we don't actually know how old anybody is. One technique that's perfectly valid, it can be helpful anyway, is to try to see if you can come up with a set of numbers that works. Come up with an example. What if? Do kind of a what if scenario. For instance, what if person A was in fact 1 year old? Then that would make B twice as old, which would be 2, and C would be twice as old as that, which would be 4, and D is 5 times as old as that, which would be 4 times 5 would be 20. And then the question asks for, how do A and D compare with each other? And it looks like, in that case anyway, 20 to 1. Does it always work that way? It's not a guarantee, but yeah, you could, try another one. If A was a 3-year-old, then B is twice that, which would make him 6. C is twice that, which would make him 12. 5 times that would be a 60. And so 3 to 60, that's also a times 20. So yeah, it's looking like a times 20 is gonna work. Basically, 2 times 2 times 2 times 5. If you want to do it with equations, yeah, you certainly can, but that technique right there was just fine. From an equation point of view, again, we have our 4 people. One important thing in word problems that it seems simple but people overlook is make sure you have names for the important unknowns, the important variables. So, you can say let A stand for the age of person A, let B stand for the age of person B, and so on. You got to have a name for something before you can put it into a formula. Okay, so then the statement that B is twice as old as A is basically just that. Then B is, remember, is like an equals, 2 times as old as A. C is 2 times older than B, and then D is 5 times older than C. Now, if you want to compare D and A, then you can go and start doing some substituting. This B here can be replaced by 2A, which gives you 4A, and then C then here can be replaced by 4A, which gets you up to 20A. So there it is in an equation format. A common wrong answer for this one was 9 times, which again is a good a good guess. 2 and 5, if you added them, would give you 9. But if you think of if you look at the examples here, these are multiplicative comparisons, not additive. Although it's a good example, it's very important to read the problem very, very carefully, because actually it wouldn't take that much of a different wording for 9 to have been the right answer. If the question had said that B was 2 years older than A instead of 2 times, and C is 2 years older than B, C is equal to B plus 2 more years basically, and D is 5 years older than C, then 9 years older would have been the comparison between A and D.